Good morning, children. In previous class, we discussed about specific heat. What is the mean by specific heat? See here, the specific heat of a substance is the amount of heat to rise the temperature of unit of mass, the substance by 1 degree centigrade. That means to take one of the substance to increases or rise the temperature 1 degree Celsius. It is called specific heat. The CGS unit shows specific heat calories per grams centigrade. Again, SI units of specific heat joule per kg kelvins. Here you can observe this table, substance given here, again CGS, again joules, the specific heat here given there. For observe lead, mercury, bronze, zinc, copper, iron, glass, aluminium, kerosene oil, ice and water. So here to observe this table, lead has 0.031 calories, again joules 130 kgs of kelvins. To compare with the lead and water is more difference of specific heat. So here water specific heat 1 to take joules 4180 kilocalories. See here, this is one of the solid. So lead, mercury, bronze, zinc, copper, iron, glass, aluminium. These are the solid state substance. Here kerosene, water, liquid states. So to compare with the solids and liquids, more lot of differences specific heat. Why the different substances specific heat different? Here, we compare with the specific heat as depends on the nature of the substance. That means we know already the substance will be made of different of molecules. In internal energies are, that means kinetic energy, rotational energy, potential energy and vibrational energies or between molecules. The total energy of the substance will be, we can call that the internal energies are including the system. So here the specific heat depends on the nature of the substance. They will ask in examination what are the SI units of the specific heat. This is the SI units of the specific heat, joules per kg to kelvins. So here you observe lead, mercury, again water. See, you can mention the 2 points very important for conceptual understand the specific heat. Here, low specific heat object gains or losses heat quickly. That means lead, mercury or low specific heat substance, they gain the heat very quickly or losses the heat very quickly. Again, high specific heat object gains or losses heat very slowly. That means high specific heat of the substance, or we take the water is more specific heat compared with the lead, mercury, bronze, zinc, copper and iron. They high specific heat object gains. It gains or receives or losses and releases the heat slowly. So these are the main two important points of depends on the specific heat of the substance. Again, we discuss about the applications of specific heat. What are the applications of specific heat? We see in our daily life, you take one of the samosa. Samosa like that outer side, very cool. But we take before, after eating in, instead of ingredients, heat. Why? The specific of ingredients is very high specific heat. Again, so we take that for eaten before very hot. Again, second one, why copper is used to for the bottom coating at the cooking vessels. See here, first example, the samosas, the samosas, the samosa. The second example is copper, copper versus copper bottom vessels. For cooking purpose, we can use the copper bottom vessels. Why? So here to compare with the another substance specific heat is high specific heat or sorry low specific heat of the copper for using the bottom vessels because it is gain the heat or lost the heat very quickly. So that purpose we can use that the copper vessels. Again, see here, I draw one of the diagram. This is one of the copper vessel. This is the handle. So, this is the low specific heat side, low specific heat, bottom also low specific, low specific heat. Again, handle will be high specific heat, high specific heat. So again, this vessel will be low specific heat to touch. What will happen? The heat will be more. Again, handle you can touch. What will happen? High specific heat will be here, including the handles. So again, cool it. So high specific heat substance gain or loss heat very slowly. Low specific heat substance will be receive the heat or gain lost the heat very quickly. So we can use the copper bottoms vessel for coating with the copper. Again, third examples of why we call the water storage house. So storehouses of the earth. Again, third one example. Third example, the sun directly delivers the large amount of heat energy to the earth. The water source and the earth, particularly the oceans, absorb the energy for the maintain the relatives the constant temperature. The ocean believes like heat storehouses for the earth. So here we compare this is our earth, this is the earth surrounding has so many oceans are there. So the sun gives the large amount of energy, heat energy. What will happen? The water receive the heat energy because water has high more specific heat. Two. These are the poles, earth Here the water will be received at the more large heat energy. Here equilibrium to get our heat will be received the water again. Therefore, oceans are moderate at the surrounding the temperature near the equator. Oceans water transfers the heavy away from the equator to the areas closer to the north and south poles. The transit of the heat falls heat help moderated to the climate to parts of the earth and therefore from the equator. Again, you take one of the watermelon brought outside of the refrigerator. It's coolness for a long time because watermelon has more quantity or a large quantity of water. Okay, so these are the applications of specific heat. Again, third one, principles of methods of mixtures. Principles of method of mixtures. So here, principles of methods of mixture. Mixtures means you take two or more substances at a different temperature or mixed with each other. Then net heat loss by the hot bodies is equal to the net heat gains by the cool bodies until they attain the thermal equilibrium equal to the temperature. Here you can observe heat lost by the hot body that equals heat gain by the cold body. So this is the principal method of the mixture. Here they asked, what is the principle of method of the mixtures? Again, net heat lost equal net heat gain. This is the principle of the method of mixtures. Method of the mixture. It is known as the principle of method of the mixtures. So here we know in previous class we note down one of the formula to find the final temperature. That means T equal the final temperature T1 M1 plus M2 T2 by M1 plus M2. This is the final temperature. Again, we discuss some of the problems based on the specific heat. Here we are using this table. So note down the problem. So this is very important. Heat lost by the hot body that equals heat gained by the cold body. For simply, net heat equal to net heat gained. Net heat lost, that equal gained. So, note down some of the problems. Calculate the problem. Calculate the amount of heat. Calculate the amount of heat required to rise require the temperature of 1 kg iron to 10 degrees Celsius. See here, you can observe this table. The iron specific heat given CGS units, again SI units. So how can you measure that the specific heat? The formula of specific heat. So we know already Q equal heat. Again S means specific heat. Specific heat. M means mass of the substance. Mass of the substance. Delta T means changes in temperature. Changes in temperature. See here, we want 1 kg iron to 10 degree Celsius. See here, the formula of heat Q equal M as the change of T. That equal the mass of the substance equal 1 kg, that means 100. Again iron mass will be 0.115. Again T temperature 10 degrees Celsius. So here I can mention the values in this formula: 1000, 0.115 into 10 degrees Celsius. That equal 1150 calories. This is the answer. So here in this problem, here given that the amount of the heat required. So we don't know the heat. Again, rise the temperature of the 1 kg. That means 1 kg equal 100 grams. Again, iron. We know here given in the table, iron, the specific heat of in calories 0.115. Again, temperature already here given 10 degrees Celsius here. So again, mentioned in this formula the total heat or temperature. So 1000, 0.115 into 10 degrees Celsius. The finally temperature we want to rise the 1 kg iron to that 10 degrees Celsius, 1150 calories. Okay. Again, problem. Find the amount of heat required to heat 1.5 liters water from 30 degrees Celsius to 75 degrees Celsius. We know already the water specific heat of water, specific heat of water that equals 4.0 4,200 calories, joules per kg calories. Again, solution. So here liter water from 30 degrees Celsius to 75 degrees Celsius. That means here in this problem they given 1 liter of water. Again, temperatures. First, to take the amount of the heat 30 degrees Celsius to rise at the 75 degrees Celsius. That means amount of water. First we take in solution amount of water. Amount of water. What is the amount of water? 1.5 liters. Again, equal to 1.5 cases. Here, again, first temperature we take T1 30 degrees Celsius and to rise T2 second temperature 75 degrees Celsius. What is the differences between the temperature? Difference between temperature T2 minus T1. That means 75 degree Celsius minus 30 degree Celsius. That equal 45 degrees Celsius. Now we calculate that the final amount of the heat. So here same formula, Q equal M S delta T. So here what is the mass? Mass is here 1 kg of liter, 1.5 kg of liter. Again, S means the specific heat of water 4,200 joules per kilo kelvins. Again, the between the difference of temperature 45 degree Celsius. The finally to rise the or to require the heat becomes 2.835 into 10 to the power of 5 joules. So this amount will be heat will be required to rise the 1 kilo water of specific heat. Thank you.